Okay, Lady Ada, happy holidays.
Ho, ho, ho! Merry Christmas.
All right, well, we have a project that we're doing. This is Cheerlights, and this is live.
It's on the internet.
On the internet right now.
Live.
We're going to show some cool stuff. But first, Lady Ada, what is, before we get into the electronics and how this color, this NeoPixel, is being controlled by anyone on the internet, what is Cheerlights?
Cheerlights is this project where people can tweet or use other social media. I've only seen it on Twitter, but there's other means which they can tag a color request with #cheerlights or @cheerlights on Twitter. And if they have a hex code or I think a yellow or green or blue color name, it gets taken off of Twitter and put onto an Internet of Things service that then other people around the world can read and then synchronize all of their lights together. So for example, you know, these lights are yellow. Everybody with a Cheerlight setup also has yellow. But, you know, somebody, for example, tweets,
everyone in the world right now.
Yeah, and if somebody tweets blue or pink, everybody's will turn blue or pink.
And we'll get to that in a second. So this is the website. And the website has a couple neat things. It has a video. It's not live. Our video's live. It just shows what Cheerlights is.
Yeah.
So that was handy. And then the other thing it has is a little square that changes color based on what it is. So I pulled that little square out here.
Yellow. And
it's yellow. And the way you know it's yellow is because if you look at our latest tweet, Cheerlights yellow, that's our Adafruit account.
Yeah, it says yellow.
That changed it to yellow, and that's also the little square color right now. So anyone come along and change it right now. If you want to, you just go to Twitter and you do #Cheerlights, and it'll change, you know, live as we do this. And the other thing is there's a chart, and it looks like
people really like orange and red.
Something's going on with orange.
There's some orange thing going on.
There's some orange thing going on. I don't know. So that's @Cheerlights on Twitter.
Well, if it really isn't Pittsburgh, you know, orange is the Flyers color.
Could be
so
gritty.
Maybe could be gritty.
Yeah.
Maybe he's spamming it.
Yeah. And you can check out the chart. You can check out the color. You can learn about the project. And it's part of ThinkSpeak. And this is the latest color right here. So let's talk about the hardware. What's the first piece of hardware you want to talk about?
Well, let's talk about how you want to talk about the NeoPixel first? That's pretty straightforward.
Yeah, sure.
Okay. So I've just got a NeoPixel ring I happen to have in my box. 16 LEDs, classic NeoPixels. You don't have to use NeoPixels. You can, of course, use an RGB LED. Oh, just turned purple.
Okay, so someone must have done
Someone is doing something on the internet.
Yeah, no, what we can do is just a quick
proof.
test.
This
well, you don't have to use Twitter,
yeah.
but let's see what happened, because I have Cheerlights here in this browser, and let's see if someone else came along. So they're controlling it not via Twitter, because you could do it a different way.
I think there's another way to do it. I just don't know what that is.
Yeah.
I'm afraid I didn't do a lot of research into this. I think you can publish directly.
Yeah, you can.
Or maybe they're using Facebook or Instagram.
There's lots of different ways to do it. So someone changed it to purple. I can confirm with that. That's on the screen.
Purple.
We changed it right before we started. So let's
okay.
So this is NeoPixel.
So yeah, you have something that can emit RGB color. So it can be LEDs or NeoPixels or dot stars.
Eric in the chat did purple. Thanks, Eric.
Oh, thanks.
Yeah.
Sweet. Nice work. Purple's a good color. So yeah, we just displayed. What's actually interesting is I wanted to make it look a little good, so I used Fancy LED, which is Paint Your Dragon's gamma correction Python library, so that it looks, you know, because the color, especially when they're very saturated, they're very almost white looking. It's like, you know, that there's so much LED that it kind of blinds you with brightness. So they're gamma corrected. So right now it's yellow. Looks like it changed.
Yeah. Okay, so someone just changed it to yellow.
Great. So that's that side of the hardware.
Yeah, and if you're using Twitter, I'll be able to see it, but if you're using it in another way, also let us know, because then we'll be able to check it out.
Cheerlights bot, maybe people
there's lots of ways.
There's a lot.
I asked in the chat.
Mystery.
Yeah, okay.
Okay, next up, let's talk about the Wi-Fi chip. The other...
yeah, so we did NeoPixel.
NeoPixels we did.
All right.
Okay, Wi-Fi. So this is an ESP32 Feather. It's green because it's an early prototype which I had kicking around. So I'm using an ESP32, and I don't have any generic breakouts. So I'm just using a Feather, and I'm not using the battery charger or the USB serial. It's got loaded onto it AT control firmware. Which basically makes it act like a Hayes modem from like the 90s. But it works pretty well, and you can send it AT commands to connect to the internet and get data. So I'm using it as a coprocessor. I wrote a guide about this like a week and a half, 2 weeks ago, but we've gotten a lot more code out for it. It's a lot more, it's working a lot better now. We've got SSL stuff working really well. We've got JSON parsing working really well. So it's actually a JSON parsed project. We go on the internet, connect to the Cheerlights service on ThinkSpeak, and then parse off the JSON. But instead of using the ESP32 on its own, I'm using it as a coprocessor. So the thing that's controlling it is a Feather M4.
Okay, and we're going to go over the code in a bit, but this is just hardware. So first we did NeoPixel.
NeoPixel.
And it's now green. Then we did Wi-Fi. And then what controls the show here?
The thing that controls the show is this Feather M4. So the reason I'm not using an ESP32 directly is because I want to take advantage of CircuitPython. I wanted to write all this code in CircuitPython because it's super fun. Stuff like JSON parsing is built in. It's like a single command. You don't have to import a library. It's built in. String management is built in. You know, writing an AT command parser manager sucks. I've somehow done it like 4 times, and it's not fun any way you do it. But if you're going to do it, doing it in Python is kind of the least unpleasant way because you can do a lot of string manipulation quite easily because Python is really, really good at just managing arrays and strings and you know, searching inside of strings and regular expressions, all that stuff. So it's using the ESP32 as a coprocessor. And then eventually I'd like to get like a small ESP32 module and maybe put it on this Feather M4 board.
Don't we just change it to red?
Yeah, it's red. You can see it's red. And then you'd have a Feather M4 with Wi-Fi built in. And you can also see there's like a NeoPixel, you know, right here. And that's actually giving me the status of the internet connection. It's actually red right now because it somehow got disconnected from the Wi-Fi. So I'll reset it. But I just committed this code like half an hour ago. So if it doesn't kick back into shape, I'll give it a reset. But some of these projects have been running overnight. And eventually, you know, it resuscitates itself. Or because I have it doing a lot of like, this is the thing with AT commands. You have to like constantly reset and check for synchronization and all that good stuff.
Yeah. So you said this is all run by CircuitPython. For the folks who want to learn more about how to do this with CircuitPython, what you could do is go to our Discord server, and that's adafruit.it/Discord. We're in there right now if you want to hang out. Cascade's there. Hi, Cascade.
There's a CircuitPython. There's a live broadcast chat, and there's a CircuitPython chat. And I've been actually working with Jerry Needle in the last week or two on this. He's actually using an argon. Yeah, so it came back up, so now it's up, and you can see that LED is white.
And you can see this is the latest color that was picked. This is the chart. Everyone really likes orange. And then the other thing that we were going to do is we're going to try to live change it here using our Twitter account.
Yeah?
So I'm going to try this out, see what happens.
What do you want to make it? Pink?
Well,
pink's good.
I was going to make it green because I think that's a nice contrast.
That's a nice contrast.
Yeah.
Yeah, orange and red are just dominating.
Live.
Oh, somebody made it white.
Somebody made it white.
That's nice.
Yeah. Live. Cheerlights. And I'm going to go green.
Okay.
So I'm going to send this off.
Okay.
Tweeted it. And this will just give us an idea of like how long it takes.
Yeah, because if the tweet has to get posted and then ThinkSpeak has to pick it up, and then we're using REST right now. I don't have an MQTT client.
That was it.
And this is yellow. Wait, red.
Oh, that was Mike.
Mike
changed it to red.
Everyone's changing it.
And then I have to find and see if I can get it to green.
I don't think your tweet went through, did it?
Yeah, I don't think my phone works.
Oh no, that's funny.
I don't think my phone is the only thing out of this that's not working.
Yeah, I'm using REST right now because it's very easy. The ESP32 has a built-in. Basically, you can do simple socket control, and it's kind of best if you are connecting to something, transmitting a little bit of data like an HTML request or HTTP request, and then getting the data back and then parsing it. So doing something like MQTT.
Green.
Not quite ready for it yet, but maybe in the next week or two I'll have an MQTT client, because then it would be instant. Because you wouldn't have to like connect to the server and get the data, and sometimes the connection is, rejected because a lot of people are connecting at once. But hopefully
between the live streaming and phones and everything, there's like a 30-second delay.
Yeah, it's green, but oddly it doesn't show up very green.
Well, it's also on a the fluorescent lighting here, but
Yeah.
you can see it's green here, and it is
Definitely green.
It is green.
Yeah.
So next up, let's talk about the code.
Okay.
So one of the things that's really hard to do is something like this in the past with Arduino or you name it, it's hard to do. This is our GitHub repo. We just posted up the code. It's
Yeah, it's in my fork, but I'm going to merge it real soon.
Yeah.
After I linked
So
it.
it's only 100 lines, and a lot of this stuff is just like comments and taking care of a lot of stuff for you. So
Okay, so let's start with the imports. So
you can go like that when you're ready.
first line, you import the garbage collector. You probably don't need it, but I've been using the garbage collector to clean up after each request. Time, just if you want to put delays in, board for the pins, bus IO gives you the UART, digital in out for the pins that you need, and then the library that actually does this is called CircuitPython ESP AT control, which is the AT command set. NeoPixels for the NeoPixels. UJSON, this is from MicroPython, and it does the JSON parsing. It's amazing. Like you give it a string with JSON data, and it just pops out a Python dictionary. It's so perfect. Compared to what this is to do in C or C++, it's just like a joy, very joyous. And then fancy LED, like I said, I'm using the fancy LED library to do gamma correction because I wanted to keep the LEDs from being too bright. Okay, so one thing I did is, because you can do cool things with CircuitPython, like have files on a file system that you drag and drop, I don't actually put the Wi-Fi settings like your SSID and password in the code itself. Instead, it's in a settings.py file, and that's really nice because I can share this code. I don't have to worry about like committing tokens or Wi-Fi identifiers or passwords. I mean, I don't think anyone's going to drive down here and connect to my Wi-Fi and steal my Netflix, but still, it's not good to share tokens and stuff. So having everything in one settings file, and I'm trying to kind of get this into the style of all of the examples, is that this is where you put all your details. Okay, and then configuration, time between query. I wait 10 seconds. I think that's polite. Cheerlight's data source and data location. So the data source, as you can see, is the API ThinkSpeak site, and we connect over REST. It's HTTP. Channel number 1417, and then I just get the feed data in JSON format. And then data location tells me in the JSON data, what is the like directory listing. You go through the feeds part, and then you go to 0, the index 0, which is that first chunk of data, and then field 2. Field 2 gives you the hexadecimal color. Okay, lines 31 through 33, I'm setting up the UART. Again, I'm doing this AT command stuff over UART, which is just amazing. I'm like running my Hayes, 19.2 modem again in like 96 compared to BBS's. It's basically just the same. Reset an RTS pin. RTS pin is kind of interesting. You can do flow control, and I found that if you want to run the modem really fast, like a baud rate really fast, you need to have flow control. So you can see here that the baud rate I'm running it is at 460-800 baud. So it's fairly fast. It's half a megabit per second. I mean, there's a lot of overhead and delays and stuff, but it does make a difference when you have big chunks of data. I do a hard reset. I think that's a good idea. You just toggle the reset pin so you know that the ESP modem will be in the same state. NeoPixels, there's a ring on pin A1, and then I'm also using the built-in NeoPixel. You can see it's board.neopixels, it's a built-in one, and I'm using that, like I said, for status to tell me, what's going on with the code. So, for example, it's blinking. That's cool. I don't know what happened. Okay. Let's see. We'll save the value in question. So I do keep track of the last value and the value, so I don't if I wanted to set the NeoPixels or play a color or whatever, set the color or play a sound. Times is a counter that I use for debugging. It's not used here, but I would actually print out how many times in a row I successfully connected. Then get value is my little helper function that will go through, it gets the JSON data, it parses it, load from a string, and then, if it parsed okay, then it iterates through the location, and then it kind of like drills down until it gets to the final location in the JSON file and returns it. Okay, so this is my main loop, right? So I have my, my setup, my loops. That was all my setup. So the loop part is first check if ESP is connected. That will tell me if I'm connected to the access point. If I'm not, I set the built-in LED to be red, and then I call ESP.connect with the settings, and it should connect to the access point, and it'll just keep retrying that until is connected and returns true. So that does all the AT command stuff. If we get past that, I turn the LED yellow. Then I will print out to the console, I'm getting the data source. Sorry, I turn it green, and then I turn it yellow, and then I request the URL from data source, and I get back the HTTP header and body. The body I'm actually not going to, the header I don't use, but if you were like debugging stuff and you wanted to see like, some X header data, you can parse through that. And then I turn the LED blue and say, okay, I got the data. And then, with AT commands, like there's always the chance of failures or timeouts. And so exceptions are really handy here because it'll just start from the beginning and check for the connection and check for synchronization. So this is where, again, Python is a lot better than C or C++. Like instead of having to check each call here and like all the different failure modes, you just do a try except, catch them all at once and start over. I don't care where it failed. I'll just begin from the beginning again. I print out the data I got. This mystery thing, this line 84 to 86 is kind of weird. For reasons I don't completely understand, the JSON data actually comes with like a number at the beginning and the number at the end. For some reason, the ThingSpeak REST server does that. I don't quite know why, so just to make it simple, I split it into lines and then I just take the middle line, which is actually the JSON data. I turn the LEDs all white. As you can see, they're white most of the time because it's got the data. And then I parse it. I call getValue to get that JSON data out. And then I just check if the the values changed, and then I kind of take the red, green, and blue out from the string because it's a hex string, and then I gamma correct it, and then set the pixels to be gamma corrected value, and then I just increment times. Finally, I do a little bit of cleanup. Again, I probably don't have to do this, but I saw with very large data chunks, I could get pretty bad fragmentation. Like if I was trying to download, 30 or 40 kilobytes of data, setting the header and body value to 0 means, they're not sticking around while I'm going to, the next loop. I garbage collect now because now's a good time, and then I sleep, and then start the loop over. So that's it. That's all the code.
Okay, we're gonna answer some questions soon. You can see people have been putting in different colors as we've been doing this. Yeah,
that's blue.
And when you go to the website, it matches up. So we're pulling this live stuff in. That's a live video feed. That's the square from the website. This is a screenshot, so it was orange, but this is the iframe that pulls in. It's a little piece of the web that comes in, and then here is the chart. That's live each time. It looks like they batch it out every hour, and then of course we have the live electronics here with all the different pieces, and that of course uses CircuitPython.
Hey, Blinka.
Yeah, there's Blinka. And so one of the things, and I'll put this here, some folks had some questions.
Yeah.
So yeah, we can answer your questions. The best place to do it, by the way, is on Discord.
Go to Discord in the live broadcast.
Yeah, we can
chat.
answer any of these questions about it. But here's the first question.
Okay.
Someone, Python's awesome, Makecode's great.
Yeah.
Will there be .star support for either one of those things?
For .star support for what?
I assume for Makecode or for CircuitPython.
I don't know about Makecode, but CircuitPython absolutely has a .star library because we just committed some code to it today.
Yeah. Looks like the person wants to know if there'll be any .star support in Makecode.
For that, opening a ticket on the Makecode GitHub repo is the best place. I think they have, if you go to Makecode, there's a place you can put in issues or feedback or requests. I think ask them. I think they like NeoPixels, but .stars shouldn't be too bad. You could also bit bang it. Not pleasant, but you could do it.
Yeah. And looks like R. Jacoby is typing up something. Maybe it's a question. And then over on YouTube, we answered my TH's question. That was a question about .star.
Yeah. Okay.
So let's go back to the tweets and see what things came in while we're doing this on Twitter. So these are ours. So that makes sense. That's the one that we just did. So Cheerlights, that's the Cheerlights one. It looks like someone made a Twitter account that specifically connects just for that. Chris Young, hey,
Oh, hey, Chris Young.
happy holidays. He put in
Merry
cyan.
Christmas to
Yeah.
you.
And then we got an ad. We got an ad from Coca-Cola.
Wait, what? Oh, yeah.
Well, because it's
I was like, that's if they're not doing cheerlights.
yeah. And then here's our turner.
Tell
count.
them, they'll be like.
So it looks like green. Green came in again. It could have been someone. And what's cool is there's a lot of different ways to change it. You don't have to just go through this.
Oh, let's go for green.
But
Thanks,
Shane changed it right now.
It's green.
Let's go for green. So it's kind of cool. And
What's funny is like there's people who are probably, it doesn't usually change that much. Although it's Christmas Eve, so I figured like if you're gonna go cheerlights in,
yeah,
tonight's the night. Like it's 9 p.m. on the
Yeah.
East Coast, 6 p.m. on the West Coast.
Skyscraper Jim did Cheerlights green. So green's popular right now. Orange you've had enough time.
Yeah,
No,
orange.
it's
Yeah, it's totally taken over. Green. Everyone wants green. Green's the winner.
Yeah.
It just looks kind of yellowish because of the color here, but it is green. I promise you.
Yeah, what I can do is since everything's working out.
Yeah.
I can show what this looks like.
Our Jacoby is asking, I worked on something similar-ish today. Will there be a show and tell this week? Yes, there will be a show and tell and Ask Engineer this week. Come on by. We'd love to see your holiday projects or non-holiday projects. Doesn't have to be holiday themed. But if it is, that's festive. Maybe we'll find the Santa hat. I don't know. We'll find it somewhere. Candy canes.
Let me,
Okay, it's pink now. Yeah, this is a good, what's interesting is I actually think Cheerlights is a really good first IoT project because it's instant, other people know how to use it, it's simple. You don't have to set up anything, the service is already in existence for you.
Yeah. So I turned all of our lights off here.
Yeah.
So that's pretty dramatic,
nice.
yeah.
So back to white, I think. Yeah. Oh, it's yellow.
Yeah, let's see how
You
long.
guys are fast and furious.
So since it just changed to yellow, we can see how long this is going to take for that to get to yellow now.
So you see the yellow LED on the right on the feather means it's trying to connect to the service.
Yeah.
Again, I think, if I can get MQTT going on this, I can. It was fast. That was like 15 seconds, but I think I can get it near instant.
Yeah.
But to do that, MQTT is a little bit. It's not a hard protocol to do, but it is not as simple as REST, where you're just like get string. It's very well defined. MQTT, there's a lot more involved.
Yeah. So Chris Anderson is going to try. Sorry, Chris Young. I was looking at tweets before with Chris Anderson. Chris Young is going to be on. He says he's going to try to be on the show and tell. It'll be his 6th anniversary.
Oh wow.
Yeah.
Cool.
And let's see what other tweets have.
Okay, warm yellow. Let's see.
Come in.
It looks like a warm yellow. Maybe it's a yellow.
It did change. It did change.
Yeah. It is yellow now.
Yeah.
All right, we're Cheerlights in here.
Yeah.
It's happening.
Yeah, I found some public domain Christmas music, so hopefully
Yeah.
YouTube doesn't get mad that I turn off the music, but it's working out.
Okay, well, this is a good test of the, we have some other example code in the repo for people who don't want lights. We have a JSON counter viewer, and we actually, yesterday we kind of went through, this weekend, we went through a whole bunch of services to find ways to get popular numbers that people want, like, YouTube followers or subscribers or Twitter followers or like number, number thingies where, we had the Bitcoin example where it's like the cost of Bitcoin. We found a bunch of other services and ways to get data, like GitHub. We got GitHub stars. For that one, you don't even need an API key, which is pretty sweet. So check out that GitHub repo and look at the counter viewer example. For some of those, again, you're gonna need an API key. But it's free to get them. You can subscribe, and then hopefully we'll have more cool CircuitPython IoT projects. I think, especially as we're moving away from supporting ESP8266 or ESP32, because we want the good experience. Having it as a coprocessor, can work quite well. Nope.
Yeah.
It's pink time. Or purple time.
I think it's cyan or something. And so if you like IoT projects and you like having them on devices, and having them open source so you know what's going on, you'll see a lot of cool stuff. I think blue looks best, by the way.
This is like the most Cheerlights in ever.
Yeah.
It's just going. It's just going.
Even matches.
How did you embed the color?
So, the video software I'm using called Wirecast allows you to embed a web page, but instead I found the iframe for the little square that's here.
Oh, it's an iframe.
And it's just pulling in the iframe, and I just turned it into a square.
That's sweet.
So
that works really well.
Yeah. So, and this is the chart. This chart's live. If it updated, it would be updated here too. So this is live data talking about live data.
There's so much embedding and
there's a lot going on.
Yeah. Looks like there's 2 more tweets coming in.
Yeah. So the other reason that we're doing this is because IoT stuff is really hard, and that's why we wanted to do something with CircuitPython. And only in a few lines of code you can do all the hard things that used to be impossible. And this is just a really good example that everyone gets. It's like, oh, I put in a color on Twitter, and this device knows what it is, finds out what it is, and then changes the color. It's a very... People get what it is. Like, oh, like anyone can start to participate. It's like, oh, I just have to type a color and it changes. And then I like that you explained the code, because you could see this isn't that complicated. In Python, it's meant to be understood when you read it. It's like, oh, I see that that's a function, and that's the variable.
Well, what I like is
there's
no mallocing, there's no unusual code, there's no string management. It's very simple compared to what it would be like to do. I mean, there are people who've done this in C, and it's not too bad if you have a lot of libraries. But I really like Python for this stuff. I think Python is a really super.
That's nice.
That's a nice, like a dark purple, maybe.
Yeah. Well, and that's the cool thing is you can really start to mess around with the colors. That's really pretty. So it's not full brightness. I think they did.
It's a dimmer color. Which is nice.
Some more stuff is coming in here. Green, purple.
Green. Oh, that green looks nice too.
Yeah. Okie dokie. All right, so that's pretty much it. We're at about the 30-minute mark. If anyone doesn't have any more questions, if there's no more questions,
we're gonna go. 1 second to put in questions. If you
have you have a couple. If you want to ask any questions in Discord or YouTube chat, looks like a few people got more of these things. Does it do hex RGB?
Yeah, the value is a hexadecimal, and that's why I have to parse it into red, green, and blue.
Yeah.
But again, what's nice is that you can use the, Python has built it. It's an interpreted language, so you can parse hexadecimal values into integers very, very easily. You don't have to do any work at all. Just cast as an int, and it comes out as an int. So the nice thing about loose typing. Green.
So you can see.
Is it like a plugin for?
Yeah, this is also another way to get live data into live video. These are some of the people that have chosen some of these.
People like the green.
Yeah. Green, purple, pink, sky blue ginger.
I think sky blue. There's only a certain number of colors supported, which I think is interesting. They didn't. They decided not to allow. Even though you get a hex value, it doesn't give you every value.
Okay.
And you don't have to do this just on Christmas. You're gonna have this year round. Don't keep yourself from the colorful glory. All right.
Okay, and that's it. Okay. So we'll have more videos. We'll probably do something. We might do something tomorrow because we have some more IoT things to test. So. Check out Twitter and our YouTube and Twitch and more.
And if you have an ESP32 of some sort and you've got an M4 board of some sort, you can try this out too, or just try it out.
You can use if you have a particle argon.
You can have a particle argon at all sorts, although I think we don't quite have an example just yet. I mean, if you hang out in the CircuitPython Discord chat, maybe we can help you out. But we're still debugging the argon. But we did get it working today, apparently. I think Jerry got it working. So hopefully we'll have some example code very soon. Also, we have post URL post data, so we can upload data. So maybe we'll have some color detector, and we can upload color to an IoT service, not just pulling data down.
Okay.
Very exciting.
And that is our holiday demo using CircuitPython.
CircuitPython. Yay!
All right, bye everybody.
Bye everybody. Merry Christmas.